All right, hello, welcome back. Day 4. This is on page 17 of your notes. All right, so when I first was doing trig, some of you might have said, "Oh yeah, we did trig last year," basics and that sort of stuff. What you probably remember from trig is referred to SOHCAHTOA. It can be written like this. If you had me last year, it was SOH, C over AH, and T over O and A. SOHCAHTOA is only done in right triangles, so you have to have a right angle. There's other kinds of trig you can do in triangles that are not right triangles, but it's not as straightforward as SOHCAHTOA. Alright, so last year, just a little bit of refresher. Some of you might remember SOHCAHTOA, but not exactly how to do it. Alright, so remember, we always are looking for a reference angle. From the reference angle, you have a side across as your opposite, or your O side. The side next to it, so that makes the right angle, is the adjacent side, or the A. And the long slant side is the hypotenuse. Start with the O, the A, and the H. Alright, so that's where sine, so sine is O over H, so it's opposite over hypotenuse. So we make ratios, we make fractions comparing the two, but this only happens in a right triangle. Cosine, or C, is adjacent over the hypotenuse, and T for tangent is opposite over adjacent. Now, the thing you weren't told last year is that, or you might have been told, but we didn't actually do last year, or you might have done a dibble. There are actually 6 trig functions. These are the first 3 basics, the sine, cosine, and the tangent. Now, the 3 other ones are based off of all of these. So if you can do sine, cosine, or tangent, we just flip them and we get the other ones. So sine, its partner one is cosecant, or CSC. And to get cosecant, we flip what sine is. You do the H over O. Now, I don't want you to memorize like these. If it helps you, you're good at that, that's fine. But really, what I'm looking for is know that sine partners with cosecant. So if you can do sine, you flip it and you got cosecant. The partner for cosine, so the flip of it, is secant, or SEC, and that's flipping the hypotenuse with the adjacent. And the tangent goes nicely with the cotangent. Tangent, cotangent. Okay, so this is cot, and that's A over O. Alright, so if I can do SOHCAHTOA, I can definitely do these 3 because we can flip them. So sine over H and H over O. Just flip them to get the other ones. Cosine, A over H, so H over A for secant. Tangent is O over A, so we got A over O. Now, one thing you may need to remind yourself is to rationalize, which means move. If you have a square root, you gotta move to the front. No decimals, all fractional answers, unless you have a nice whole number. All right, so find the 6 trig functions of theta. So theta, here's your reference angle. Across is opposite, next door is adjacent, and this is hypotenuse. The hypotenuse is always across from the right angle, so longest side every single time. Now, since I don't have a number here, I need to figure it out. So I'm going to do Pythagorean theorem. So if you're ever missing a side, you want to do that. A squared plus b squared equals c squared. So you have 2 squared plus 5 squared equals c squared for excuse me. Okay, so square root of 29. Do not make a decimal. Leave it as the root of 29. If it was something like the root of 24, we could reduce it to 2 root 6. But otherwise, we're leaving them like this. Okay. All right. So sine opposite over hypotenuse 2 over root 29, which means for the cosecant, I flip it and get root 29 over 2. Cosine is adjacent over hypotenuse, so 5 over root 29, which I flipped for secant, so root 29 over 5. Tangent is opposite over adjacent, so 2 over 5. Cotangent, you flip it and get 5 over 2. Now, the majority of these are fine. Cosecant's fine, secant's fine, cotangent's fine, tangent's fine, but we have to fix sine and cosine. And it's not that you have to do them every time, it's just because there's a square root in the denominator. So just a reminder, we multiply by whatever the square root is. And really, essentially what happens is the root moves to the top and we just have the whole number on the bottom. So this becomes 5 root 29 over 29. Okay, if we have to simplify, then we simplify, but there's nothing else to do. Okay, so those two are fixed. We have the rest of them. Given sine of theta is 2 over 3, given a sketch of the corresponding trig functions, that sort of stuff. Okay, so this is kind of like figuring out what you have going on. Sine for theta, which is opposite over hypotenuse, is 2 over 3. So that means opposite gets 2, hypotenuse gets 3. So remember, go across. Again, Pythagorean theorem. X squared plus 2 squared equals 3 squared, 9, 4. X squared equals 5, root x equals the root of 5. Alright, so find the other trig functions. So I have sine is 2 over 3. So I'm going to find cosecant, and I'm putting it across because it works with sine. Cosine with secant. Tangent with cotangent. Okay, if you think you're good making the ratios, pause it here and then double check everything. Root 3. This is going to end up being 2 root 5 over 5. This is 3 over 2. Secant is 3 root 5 over 5. And cotangent is root 5 over 2. This is where we are going to stop for today. So make sure you get this stuff down, get all the notes done. For tomorrow, have number page on page 19. Have all these done up to number 6 for your homework. Let me know if you have questions. Thanks. Bye.